Let's wait for 2 minutes, then after we'll start. Who is joining from ET time, John? I think for them it's too early in the morning, looks like it. Rishi, shall we start?
Yeah, let's get started. Hi all, thanks for joining the KubeSlice office hours. Let's get started with a quick round of introduction. Hi, I'm Richie Sebastian. I lead the DevOps engineering team within Navisha. I have Imran with me, who leads the backend
Yes.
engineering. And I have Bharat, who is a technical architect, and he leads all the solutioning part on the KubeSlice and the other products that we have within Navisha. Right. With that, yeah, sorry. So with that, let's get started. I'll kick off this KubeSlice office hour with explaining the need for KubeSlice, and maybe we'll talk a bit about the agenda. We'll start with a high-level overview, which will be provided by Bharat, and then we'll have a quick demo on the KubeSlice capability, which showcases the distributed applications connectivity across multiple cloud providers. And then Imran will talk about upcoming roadmap and the releases. And lastly, he will also explain the open source contribution guide and how to get started in case you guys are interested in contributing to the KubeSlice, right? Yeah. So as more and more organizations are adopting multi-cloud services and strategies, right, for deploying applications using open source technologies like Kubernetes, which provides them flexibility and portability to build and optimize applications on cloud and computing environments such as AKS, EKS, or GKE, or you can consider any of the Kubernetes platforms that are available in the market, right? There's a lot of challenges that they face, but one of the key challenges that they face is basically how to establish a secure connectivity across services. When you have every cloud provider have their own connectivity solution, or their subnet range, and one of the other problem statements that they face is the IP address overlapping. So that's where KubeSlice comes into the picture. KubeSlice is basically an overlay network. It basically helps applications that are distributed across cloud providers running on Kubernetes to establish addressing address space with the help of that KubeSlice overlay network, and it basically helps the services to connect to the slice endpoint, which basically establishes the connectivity in form of a service mesh, right? So it's basically a service mesh at layer 3 with reduced complexity of a mesh, actually. So with that, I will hand it over to Bharat, and he can talk more about the KubeSlice and its components in detail, actually. Yeah.
Thanks, Richie. So the KubeSlice architecture contains a controller cluster and a number of worker clusters. So the controller cluster is like the central configuration manager for all the features of KubeSlice. There is a cluster registration mechanism through which worker clusters can register with the controller cluster. So once the worker clusters are registered, the user can proceed and create a slice. So a slice is basically an overlay network that spans across multiple worker clusters. And the user can associate namespaces running in different clusters to a single slice. And the slice and the pods that come up in these application namespaces are automatically connected to the overlay network, so that we provide pod-to-pod L3 connectivity for all the pods across the clusters. All right. So there are a number of features, components of KubeSlice. Let's go back. Components of KubeSlice on the worker cluster. There are a few cluster scoped components and a few are slice specific components. So the cluster scoped components are basically the important ones are the operator, slice operator. So the slice operator is like the main orchestrator or coordinator in a worker cluster that listens to configuration updates from the controller cluster, and it communicates with a number of other components on the worker cluster to set up the overlay network and to establish different features of KubeSlice. So one other cluster scoped component is NSM. So NSM stands for Network Service Mesh. It's a CNCF certified open source project, and KubeSlice depends on NSM to set up the data path for the overlay network. So NSM is responsible to insert virtual interfaces into application parts. So KubeSlice is CNI agnostic, which means that you could have any CNI running on the worker clusters, and they could have unique or distinct pod and service subnets. KubeSlice does not really rely on on CNI. It inserts a new interface altogether into the application parts to set up the overlay network. So it inserts an interface in the application part and connects it to something called a slice router. So a slice router is a per slice entity. So every slice would have a slice router in every worker cluster. So slice router is a virtual layer 3 device, which basically routes traffic from the application pods on one cluster to application pods on remote clusters through something called the slice VPN gateways. So slice VPN gateways are actually the points of egress and ingress for a slice for east-west traffic. So east-west traffic is basically traffic flowing between the worker clusters, and the slice VPN gateways are the one that actually act as ingress and egress. So for every pair of clusters, the controller assigns the role of server and a client for the clusters in a cluster pair. For the server cluster, we create an OpenVPN server pod, and on the client cluster, we create the OpenVPN client pod. So the client makes a connection to the server pod over the internet or whatever the intercluster underlay is. And once the connectivity is made, a tunnel interface is created on the pod on both the VPN pods, and a VPN tunnel is established. So this tunnel is encrypted, and all the intercluster application traffic, traffic flowing from one pod in cluster 1 on worker 1 to a pod on worker 2 goes through the VPN tunnel, and all the traffic is encrypted. Right. Yeah, I guess we can move on to the next slide, Imran. Okay, so
Sure.
this slide lists all the basic features of KubeSlice. So like I mentioned, it basically provides multi-cluster connectivity. You could have on-prem clusters, or you could connect on-prem clusters to any of the cloud provider clusters. Those cloud providers clusters could be public or private. So we basically create a flat L3 network between all the pods that come up on these clusters. And we are CNI agnostic. Like I mentioned, it does not really matter who is the CNI provider on the clusters and what is the IP subnet range that the CNI is using for the pods and services. We also provide full mesh connectivity. In the previous picture, I just showed worker clusters, but you could have more than 2 worker clusters. In that case, we provide a full mesh connectivity for all the worker clusters. And you could have namespace association, as in you could have namespaces in different clusters be associated with a single slice. So it's basically like grouping namespaces across multiple clusters. And we provide something called microsegmentation in the sense that we isolate those namespaces from the rest of the namespaces on a cluster. So any other namespace which is not associated with a slice cannot really speak to a namespace which is part of the slice. So we provide namespace isolation. So this feature can be turned on or off on demand at runtime whenever the user desires namespace isolation and microsegmentation. There's one other feature called QoS policies, where quality of service. So you could specify bandwidth limit on the intercluster traffic that flows over a slice. So you could have like high priority slices and low priority slices, and you could assign higher bandwidth to your high priority slices compared to your low priority slices. And you can configure the bandwidth limit yeah. And one other important feature is the service discovery. So you could export service from one cluster, and KubeSlice automatically imports that service on all the other clusters of a slice. So we have, this is actually accomplished using CRDs. So the controller cluster acts like a broker or a facilitator for service import and export. We also provide a DNS lookup for imported services. So a client can simply make a DNS query to get the endpoint IP of the pod which is running on a remote cluster and connect to it. And if you have Istio already running on your clusters, then we are interoperable with Istio. You do not have to change anything for KubeSlice and Istio to operate together. You could actually make KubeSlice spin up Istio ingress and egress gateways if you have such a use case. In case you want all the traffic, east-west traffic going through Istio gateways for whatever reason, for monitoring or for say HTTP header manipulation and things like that, you could actually configure KubeSlice to spin up Istio ingress and egress gateways. And you could also have MTLS, Istio MTLS peer authentication, wherein you can have a common root CA across all your worker clusters and make Istio use the common root CA to create certificates for workloads. And you could use Istio MTLS as is along with KubeSlice if you want higher security. Anyways, we would encrypt all the intercluster traffic, but in case you would need one more layer of security on top of that, you could use Istio MTLS peer authentication with KubeSlice. Yes, we can go to the next slide. Probably I'll pause for a bit and see if there are any questions so far. All right. So I just wanted to show you the life of a packet. So the interfaces, and so these boxes are pods, and there are two types of interfaces marked on the pods. One marked in green is the NSM interface that KubeSlice injects. The one in black is the CNI interface that the CNI running on the Kubernetes cluster inserts. So the green lines are the OLA network that KubeSlice creates between these two worker clusters. So if you notice, there is a slice subnet there, 10.1.0.0/16. So when the user is creating a slice config, the user would also have to provide a subnet, /16 or /8 or whatever, a private subnet. And it is statically divided between the worker clusters by the controller first. And once a pool of IP addresses are assigned to each worker, within that worker, the IPAM is done by the slice router dynamically. So the interfaces that are injected, they need IP addresses to be assigned, right? So that is handled by slice router. So once it gets the pool of IP addresses from the controller, it basically uses that pool of IPs to assign to the application parts on a worker cluster. So if you follow the arrow from cluster 1 to cluster 2, the pod on the upper left corner, it goes from the NS1 pod to the slice router, from the slice router to one of the VPN gateway pods. So if you notice, we have two VPN gateway pods. So we have redundant pairs of gateway pods just for high availability. In case we try to place these gateway pods on different nodes. So in case there are any node failures or node restarts and things like that, we do not actually lose connectivity to the remote cluster. So the slice router actually distributes traffic between these two VPN gateway pods. So we actually use ECMP to distribute traffic between the gateway pods. So if you follow the arrow, the traffic goes from the slice router to the VPN gateway on the left, and it flows through the VPN tunnel over the internet or over any underlay, and it hits the VPN gateway on the remote cluster on cluster 2. And the VPN gateway then forwards the traffic to the slice router, and from the slice router onto the application pod in NS1 on cluster 2. So all the routes in the slice router and the VPN gateway are installed by the operator, the slice operator. So there are a number of components. So there is a slice router sidecar, and the operator speaks to that sidecar to install the routes. Similarly, on the VPN gateway, there is a sidecar server which the operator talks to and installs the necessary routes. So the routing complexity kind of increases when you have like more number of worker clusters. So all that complexity is managed by the controller and the slice operators in each worker clusters. All right, so I guess I'll pass over to Richie for a quick demo and probably a description of use cases.
Sure.
Thanks, Bharat.
Thanks, Bharat. So before we go over the demo, I have listed out some of the use cases. So one of the common use cases nowadays that we see is, there's a lot of high velocity streaming applications that we run, and then like everybody is using Kafka. Of course, there is a lot of managed services nowadays available, but there's nothing beats basically running Kafka, right? So that's where you want to set up a high available Kafka setup, which is spread across multiple cloud providers, and that is where KubeSlice solves that one problem with the help of that logical construct called slice, right? One of the other use cases is running databases like MongoDB. So if you just look at the normal MongoDB operator, which basically is one of the standard solutions that is provided by MongoDB for running it on Kubernetes. It basically comes with an operator, but then it doesn't talk about how to spread that MongoDB solution to a multi-cloud solution or a multi-cloud deployment, right? So that's where you can use KubeSlice to basically set up a MongoDB slice, and basically you can connect multiple MongoDB clusters that spread across different cloud providers, and you will see like it basically works like a big cluster, that is big MongoDB cluster, which is highly available, and it is basically resilient to the cloud failure, individual cloud failure, not just the region failure, right? Distributed services deployment across cloud and edge clusters. So that is one of the use cases, and that is again part of one of the demos that we'll have it in just 5 minutes. Pod to pod MTLS across the clusters, right? So we already discussed, I think Bharat already explained the pod to pod communication that is there. So we also take security seriously, and that's where you can implement MTLS with pod to pod communication, right? It's not just pod to pod communication; it's basically pod to pod communication with MTLS, right? Of course, there's a lot of solutions which talks about layers and capabilities with Istio, but we work at layer 3 connectivity, and that's where you can use any services which are TCP or all the standard services, or any middleware or any database services that leverages TCP and UDP protocol for communication, right? So yep. Okay, with that we'll quickly jump into the demo for today. So let's go over the demo topology that we have. So we have two standard demos that we have set up. One is the Iperf. Iperf is basically nothing. It's a client server topology. So for the demo, what we have done is we have deployed a Iperf server that is running in one of the cloud providers, and then we have two different clients, which basically connects to the same Iperf server, but it goes over the slice and it establishes this connectivity. And for a real world application, we have this Boutique. Boutique is a very standard application provided by Google. So it basically consists of multiple microservices. So for the demo, what we have done is we have deployed the backend services in one of the cloud providers, and then we have two different front-end services, like edge service, like cart service or checkout. We'll go over that services in the detail in when I share my screen. Connected to the same backend. So instead of this cloud, it can be a edge location, it can be a data center, it can be any cloud. Right? There's no restriction on any of the cloud platforms that we can use. Right? Yep. Okay. With that, let me share my screen and let's go over the demo.
Sure.
Okay. So as I discussed, we have this one cluster that is running on AKS, that's running on Azure, that is AKS, right? And if you see, you go to the boutique namespace, we have these backend services, ad service, currency, email, payment, right? And we have another cluster that's an EKS cluster where we have this boutique namespace where you have these front-end services, typically cart, checkout, front-end, and rest of the front-end service. And then we have one more GKE cluster that's running on Google Cloud, where we have the same namespace, but only the front-end services, right? And now if we look at the website, so basically this is the GUI for the front-end that is running in GKE. So if you see this service, basically has this, sorry, it's basically we are using this node IP. So we are using this node IP and the port. So let's just quickly, add some item into the cart. Right, and it's a vintage record player that's of $65.50, and yep. So the total becomes $84. Okay. Now the transaction is complete. So this transaction will again go to the backend cluster, which is AKS in our case. And if you see, the request was processed for $84.63. And this matches the transaction paid, right? And the request was set by the same backend cluster. And if you similarly go to this cart on EKS, you add an item, it's coming out to be $77.94. Place the order, right? And you should see the $794 was served by the same backend, right? Now let's just understand, what happened here actually, right? Since the front end is running on since the front end is running on two different cloud providers, and you have the same backend that is basically the payment service and the ad service currency all running in a in a different cloud provider. So what we have done is we have established a slice. So if you go to the controller, for a project construct, we have this project namespace, right? And this slice is tied to the project namespace. And if you see the topology here, what we have done is we have created a slice which basically cuts across 3 clusters: worker 1, worker 2, worker 3, and then it's tied to the namespace called boutique. That is our application namespace, right? And just to understand the concept of NSM, let's go into the next demo. It's basically a another slice that we have set up. You see the slice that's called Iperf slice. So again, let me just show you the topology here. So we have worker 1, worker 2, worker 3 cluster, and in all these clusters we have a namespace called Iperf, and it's connected using the slice called Iperf. And if you go to the topology of Iperf app, we have the, let me go to the pods. We have a sleep pod, that is a Iperf client pod that's running in AKS. And if you go to Iperf namespace here, we have the server pod that is running in EKS. And then if you go to there's a client pod that is running in GKE, right? Now, just for the demo, what we can do is we can get into the Iperf pod, right? And we can try to connect to the server. So we are making a call from the client to the server, right? And if you see here, it's able to connect. But the point to be noted here is the IP. And if you consider this IP, this is going to be the NSM IP assigned to this the pod, right? That is the server pod. And if you see, there are a couple of sidecar containers that are running along with the application. There is this CMD NSE sidecar, and then there are some init container that that is there, right? Yeah. So basically, whenever you try to establish the connectivity using the slice DNS, it basically resolves to an NSM IP, and each pod that is part of the slice gets an NSM IP, right? So if you look at any pod, right, it has a different NSM IP, right? So it doesn't matter what is the CIDR addressing of your nodes or of your pods, right? Let's just, if you're running a workload on EKS, you have a dependency of VPC subnet. So typically, in most of the cloud providers, they use the VNet based IP addressing, where the IP address of the pod is nothing but it's basically the secondary IP address of the subnet, right? So that's where you and then if you're running the workload in enterprise, you are running the workload in a private subnet, and there's a limited private subnet, right? So there's always a possibility of IP subnet overlapping, right? So that basically, if you see NSM, NSM IPs are that are part of the slice overlay, basically helps you to overcome this challenge actually, right? Yeah. Any questions? Let me stop sharing the screen.
I have a question, but it's end of the presentation. Can it be any questions?
Yeah, Maris.
Okay, what's happen? Yeah, going back to the slide. What's happen if the controller cluster is down?
Right. That's a good question. Bharat, you
Yeah.
want to take it? Yeah.
Yeah. So the data path is across between the worker clusters. So the data path is interrupted if the controller goes away. So you would only not be able to change the configuration or update the configuration until the controller cluster is back up again. But the data path is not interrupted.
So they are still connecting, but it's not impacting. You can do any kind of work even if it's down, the
Yes.
controller, right?
So if the controller is down, yes, the data traffic would still be flowing.
Okay. The second question, you mentioned namespace isolation you support. Are you adding some extra feature? I mean, compared to the Kubernetes namespace, or what you bring?
Right. So
I mean,
by namespace association, what we mean is you could have different namespaces in different clusters.
no, isolation. No, namespace isolation. Yeah.
Isolation, right? So isolation is basically so you have a bunch of namespaces on a worker cluster that you associate with a slice, but you could also have some other namespaces running on the cluster, right? Which could be running some other application which is not really connected to the slice. So by isolation, right, what we mean is those other namespaces would not be able to communicate with the namespaces that are part of a slice. For example, in the boutique demo, the boutique namespace is part of a slice, but you could have some other namespace on your cluster, say, for example, Iperf, right? And the Iperf namespace cannot speak to the boutique namespace if you have enabled namespace isolation.
I see.
Yeah, we block the traffic from the non-slice namespaces.
Oh, okay. But you are still see other, let's say, some of the objects.
Yeah.
It's kind of similar with the Kubernetes namespace. With other things.
Right. Yeah.
It's acting as a okay.
Right. So you have to do this without KubeSlice with plain Kubernetes, then you'll have to create and manage network policies.
Yeah.
So we would do that automatically.
Okay. The last question, you specify also MTLS. Is this based on the Istio?
Right. I mean, if you want to enable MTLS across two different clusters, right? So you have a client on cluster 1 and you have a server on cluster 2. And if you want to enable MTLS between them, then you need a common root CA, right? Who is creating certificates for your servers and clients.
I see. Okay. So Istio, it's a requirement actually for this kind of feature.
Right. Yeah. So Istio on these two clusters would have to rely on a common root CA. They could have intermediate CAs, but they need to have a common root CA.
Okay. Cool. Okay. Thanks. Yeah.
Anyone else have any other questions, guys?
You mentioned a registration process that happens in the beginning. Can you please detail a bit this step? What happens during the registration?
Sure. So the user would create a CRD. We have a CRD called the cluster CRD. So the in the specification of the cluster CRD, you would have to specify a name for your cluster and a bunch of other things. So once you create that CRD and on the controller cluster, that's how you register a worker cluster. And the next step would be to install the KubeSlice on the worker cluster. And once the KubeSlice components in the worker cluster come up, they connect to the controller cluster. And the controller cluster recognizes or identifies the connecting cluster and makes sure that cluster is registered through the cluster CRD. There is a matching, then must be a matching CRD for the connecting cluster.
Okay, thank you.
Any other questions we have, guys?
Okay. I think if you have no questions, then we can move to the next step. Yeah.
Thank you. So if you want to learn more about KubeSlice, you can visit our GitHub repository where you can find the source code, our open issues, pull request. The link for our GitHub repo is github.com KubeSlice. Let me show it to you. So this is our repository. Okay. You can find some bunch of detailed documentation in the top. And if you come down, you will see some of the pinned repositories. We have pinned some repositories over here. Work operator, KubeSlice controller. We have docs, and there is something called KubeSlice. So KubeSlice is basically it's a Helm repository. So every release we package our different component and put as a Helm package over here. So yeah, I recommend to please add this Helm repo add and try to install in your local or in any cluster you want. Beside this pin cluster repositories, we have other repository also, which we encourage. Please go over those. Try to see, try to get idea about something. Try to figure out how the components are communicating with each other. So pretty much it. Next step, you can also check our documentation website where you can find the installation guide, user manual, playground, sandbox, other references also. So even you can learn more about the KubeSlice because this 1 hour call is not sufficient, right? So you can go over the documentation, you can see how the KubeSlice works, what are the different components. As right now, I think we asked like how the registration happens. So those things you can go over the documentation and you can figure out how exactly the whole setup is working. What are the different installation steps if you want to do manually. The link for the documentation is kubeslice.io. I'll go over the website also. So this is our documentation. If you see, we have what is KubeSlice, we have high level architecture, we have components, key features, we have installation steps, manually how we can do the installations. We have troubleshooting guide in this. If you're stuck someplace, which you probably can get from help from here to figure out what exactly the next step you're going to do. I want to grab a couple of minutes of your attention to the playground. If you see, there is something called under our documentation playground, and there is called sandbox. So Avesha provides 4-hour free access to our sandbox account, where you can play around with our KubeSlice. You can try yourself. You can see how the things are working without spending, without installing locally or directly installing to your clusters. So for that, what you have to do is you have to go by the registration process. This is the link. You can figure out. You will just get this one from the website only. In this link, if you see, you have to just give the company name, and your email ID. After that, after just few minutes, you will get a credential of a VM. Okay. And this VM is a tailor-made VM. That means it have all the dependencies and it comes out of the box with our CLI binary also. So when you log in, after that, what you have to do, you have to just run this command. KubeSlice CLI install profile full demo. So what it will do, nothing, you have to not install anything. Everything comes out of the box. So what it does exactly, it will set up everything for you. It installs kind cluster, 3 kind cluster. 1 will be controller, 2 will be the worker, and it will create some demo slices for you also to understand how the things works. And you can play around after that one for 4 hours to understand exactly how our product works. You can get more information about KubeSlice CLI. This is another tool we have where you can use this one to install in your local system, any clusters from any kind of laptop you have, like we have a OS, Windows OS, Linux OS. So we have also this support right now. So you can go over this documentation also. Let me go quickly to the next page. Guys, first of all, do you have any question around the sandbox, repositories, or any other stuff?
That script which installed KubeSlice, it is
Yes.
also available on the GitHub, right? On the GitHub. It
Yes.
is under the KubeSlice repository?
Yes.
Cool, thank you.
Yeah. For the release and roadmap, we are excited to announce, like we have released our new version of KubeSlice 1.2.0, which adds support to the load balancing services that enables you to connect your private and public clusters seamlessly. We encourage you to, as I said, so the step, right? You can go to our KubeSlice repository, try to add your Helm, and please explore our newest feature right now, so that you guys can do. And I would like to share with you the current status of our roadmap for KubeSlice. You can find the roadmap on the GitHub under this link, but there is an easy way to get this to link also. So you can directly go to our KubeSlice. You can go to the project. In the project, if you see, there is one project is open, KubeSlice roadmap. it will land to the same place where this link will go. Click after clicking this link will go to. So currently, right now we have 4 open issues. Right now we are working. These are the 4 open issues: reconcile port number in the OVPN, reject conflicting port distribution budget of the slice gateway, and there is one bug also. So thanks to our contributor, we are on track to release our updated version 1.3.0 very shortly. In that, which probably we have one feature where we are trying to give a port distribution budget for the slice gateway ports. And other 3 are the enhancement bugs, which we're trying to fix with the release 1.3.0. Just let me get quickly. So these are the 3 bugs. 4, I think I missed one. And we're going to release probably in coming months 1.3.0 with this feature and few bug fixes. So for the contribution, I'll try to encourage guys at least start looking with the different repos. If you want to start with a very small, you can go to the docs. I'll take the example of a docs repo only. So to raise a issue, it's very easy. You can go to the issues. We have mostly in our all repos, we have a templating of the issues. So if you click on the new issue, like let's consider in a documentation, you find some spelling mistakes, some design issues, some kind of a gap, some kind of a wrong information you can find in this one. So the best way to encourage, I can encourage you to start with the raising an issue in the doc. So we have a format all over the repos. You will find the same format. You can either request for the enhancement, or you can go for the doc issues, means issues. So in this condition, let's consider you figure out there's a spelling mistake in the website. So you can give a title. You can choose what type of issue is this from this. You write some basic description, and it will be helpful to any contributor to understand what is the location exactly the issue is. So let's consider, I'll take an example. We have in the key feature, there is a mistake, a spelling mistake, or some kind of an issue with this one. So I'll copy this link. I'll paste it over here in the location, and if you want, you can give suggestions also, like I think this will be fixed like this, or this right spelling of this will be this. That's how you can at least start your first issue, right? And similarly, as I mentioned, we have other repos also. If you go through the controller, worker, operator, we have the same format right now, the issues. You can go to the issues, you try to either create a bug or the feature in this one. So this, at least we follow around all our repos right now. And any kind of enhancement also we take. So let's consider, as I mentioned, if you want to give any enhancement rather than issues, so you can also request for that one from here, where you can again mention the title. What is the area of enhancement you are thinking right now? What is the description about that one, and suggestions. So this way, at least we will get the idea exactly. There is some issue, there is some enhancement you want to do in the website or any other repos. So it will help, a great help for us. We would love. Yeah. Hello. Any questions, guys?
Yes, I have. Let's suppose that some of the contributors, they open some issues on the KubeSlice repo. How you select, or how you prioritize if there are many issues which are critical?
So I think I can take an example over here. Let's consider we have the same scenario right now with the operator right now. So if you see, we have lots of issues open right now in this one. So we choose on the like exactly if it is a breaking issue, like what are the other bug fixes we are trying to do this time. Those are the issues we without like this is a very corner case we want to fix as soon as possible. And for the enhancement, we try to discuss it first, like is it really required right now, or we can wait to go other enhancement in the first. So for enhancement, we probably discuss on the order. For the bug, we need to figure out, is it really a pressing issue, or it just we can take it little later. So that's how we assign one by one all those bugs. And also, this is the thing, this is the way, this is the call exactly we want to this is office hour. That's why we have the office hours, right? So we want to discuss, this is the issue. Somebody opened the issue. Is it, we try to discuss over here. It's like it is pressing issues. We want to fix it first, or we can wait for the other issue to be fixed first. So this call will be in the future to decide and discuss that. And other than that, also, as I said, for enhancement, we need to discuss more before we want to hand touch. But for the bug, we probably try to see exactly, is it making sense or not? And we can discuss about, like, let's consider someone raised the bug. So we can discuss all this in the thread right now also. Okay, what do you think about this bug? Who want to fix it? Is it so pressing issue? It's other people are also facing or not? So those are the parameter we choose to decide, like which one will go first, which will go second in the priority.
Is based also on the vote. I mean, if there are many people who vote actually this issue, you are taking care in consideration also this vote, like,
yeah, kind of, you can say.
times up.
Yes,
Okay.
yes, you're right. Yes, you're right, 100%. That's we do. Because from the comments and the discussion, we understand from the vote, okay, this is the one we want to pick it up first. So that's how we do. Thanks for the question. So for the other contributions guide also, you can, in each repo, you will find our contribution guide. It's simple. You can contribute our code base. You can, as I mentioned, you can report, trace the bug. You can answer, and in the KubeSlice discussion forum, you can write technical document. You can fix issues, anything. That's, everyone is welcome. Our compliance is very simple for the DCOs. We want to be signed off all our commits, which is coming to our any of the repos, right? And the workflow is similar to the any other open source repositories. You fork our repo, you clone in your machine, you commit some changes, and you just raise a pull request after that one. So it's simple. Yeah.
I have another one.
Yeah.
How the guy who opened the issue know you work on that task? You put a specific tag. Hey, this is in the. We'll work on that, or how the guy is.
So if
it knows, hey, someone is working right now on this.
Okay.
Issues.
So if you see, there is an assignee we have, right? So we that's how we know he's going to work on this one, and it is started working.
There.
Yeah. So it's not like a random decision. We do discuss first in the thread. If you see, there is some of the guy wanted to like pick up some issues. In this example, you can see. So I'm researching on the issue. Will come up with the approach soon. Can you assign to me? So we happy to assign, because someone contributor wanted to work on this one. This was the open issue. If you see, this is open from the October 9. So that obviously from there you can somebody is asking to be assigned those guys, and when we know the people is working, that's a roadmap I discussed earlier, right? I'll again explain to that. In the roadmap, may put that issue to in progress. So if you see the roadmap, this is how it looks like. So this 4 thing which I was mentioning, if you see, it says in progress. So it will be this is the tracking mechanism. So it says in the worker operator, this 4 worker operator, this 4 issues and in progress. Someone is working on this one. This is not assigned to anyone. This is done, and this we want to pick next. It is in the to-do step. So that's
okay. So there is on the pull request, there is a task. I mean, the task from the roadmap assigned there, so you know if it's in progress or not. Okay.
Exactly. So this is how we know. So this is our tracking. This is kind of, you can say, Jira for us. So this is where we know like which issue is assigned to whom, and what is the status of that issue right now? Is it work done? Is it not picked up? Is it in the progress? And exactly which repo is it? That also we can see from here also. So that's how it is.
Okay, cool.
Any other questions, guys? Okay. So we would love to have your feedback and contribution. You can find the source code documentation on GitHub. As already I show you the link I shared in the meeting chat also. So please take a look at the repos, give them a star. Feel free to fork, clone, submit pull request. You can raise issues, suggest features, You can report bug on the GitHub issue tracker, as I showed to you guys earlier. If you have any questions or comment, you can join our Slack channel. I think that link, I hope somebody already shared in the meeting link also, where you can chat with us, other contributor also. We hope you are interested in the KubeSlice, want to help us build this amazing tool. So basically, we appreciate your time and attention, and we look forward to hear from you soon, guys. Till we meet again, have a wonderful day. Keep smiling. Thank you. Any last questions or any confusions or any kind of?
I have a question, Imran. Do we have any goodies for open source contributors?
I think the discussion is right now going on, probably because we wanted our earlier, early contributor to have something. It's not announced yet officially, but we will have very soon.
Okay.
Thank you. So anyway, we have a few minutes left. Guys, you have any other question related to contributions or related to like designs or the KubeSlice? You can fire away.
Yeah, cool.
Okay. Nice discussion, guys. Thanks a lot for joining again. Please go to the repos. Any help required, you just come to our Slack channel, discuss. Probably anytime people will be responding to you, especially from India IST time. And let's try to build this amazing tool help us to build this amazing tool. Thanks, guys. Thanks a lot. Thanks for joining the call. Thanks for your time.
Thank you for your
Thank you.
presentation.
Thanks, guys.
Thank you very much.
Yeah. This recording will also be
you.
available on the YouTube.
So
And,
someone is missed. If you want to share, you can also share
Yep.
with them.
Yep.
Thanks a lot, guys.
Thank you.
Thank you very much.